how ecosystems work. Good morning. So I know we talked a lot about this. Again, just remember, when we're looking at any kind of biomolecule, this is an amino acid, which is the monomer or building block of proteins, that the atoms are nutrients, the bonds are the energy. Energy goes one way in an ecosystem. It's created and then it goes, the amount of usable energy goes down until it's gone and then it needs to be replaced. So energy needs to be constantly replaced. The nutrients, once these bonds are broken, the nutrients can be used over and over and over again. So we have what are called nutrient cycles. Nutrient cycles are referred to as geochemical cycles. So we've got a few important parts of words in here. Bio meaning living, geo meaning non-living or kind of like rock type, any kind of geology belonging to the earth. Chemical meaning anything that is made up of atoms. So you've got a few things in here. What that means is that we have a cycle, so something that goes round and round and round, that involves going through the earth and through living things. So back and forth between the earth and living things. So think like soil into plants, gets eaten through the trophic levels, dye, waste, goes back into the earth. The nutrients get recycled back into the autotrophs, go through the trophic levels, we die, have waste, goes back into the earth, and you have that cycling of chemicals, and the biomolecule groups are chemicals, carbon dioxide and oxygen are chemicals, and so we have the cycling of all of these things that are the biogeochemical cycles. So first example is carbon. Carbon, you can see, like if we look at this amino acid, carbon is super important because it is the main framework of the biomolecule groups. In this amino acid, we have what we call a central carbon. Everything else comes around this carbon. That's why we call it a central carbon. Carbon's also a really good framework for all the biomolecules because it has the ability to bond with 4 other atoms. So you can see here that you've got something down here, over here you have a group, over here you have a group, and over here you have a group, all around that central carbon. Carbon also is important in terms of we give off carbon dioxide as a waste product of our metabolic processes, and that carbon dioxide is then utilized by autotrophs. They use the carbon dioxide to create our food and oxygen. So carbon, again, is really important in the central framework of all of our organic molecules and that cycling of carbon dioxide and oxygen. Carbon dioxide goes into the atmosphere. The producers are going to extract that carbon dioxide, use it in the process of photosynthesis or chemosynthesis. Then that carbon dioxide is going to be incorporated into our biomolecules. It's going to be passed on through the trophic levels or going to be passed on to the detritivores and decomposers when we have waste and we die. So we have this cycling, and then the nutrients of that carbon are going to, by the decomposers and detritivores, be made available back to the autotrophs, and then we have this cycling again. Carbon is also returned to the atmosphere when you exhale or respire. Any living thing, when they have the process of cellular respiration, will give off some carbon dioxide. Carbon dioxide is also a sink into the oceans. That means it's absorbed by the oceans. One of the things that happens in the oceans is that carbon dioxide is incorporated with calcium to become calcium carbonate. And we see a lot of the mollusks, for example, are going to take in that carbon dioxide, calcium, make calcium carbonate, and form their protective shells on their bodies. Eventually, those things, the calcium carbonate becomes part of the basis of a lot of those ecosystems where things grow in. We now know it as limestone. The Chicagoland area has a bed of limestone, and so what that tells us is that millions of years ago, this was ocean here, and there was coral reefs here that had reefs that left behind limestone. Carbon is also used in the production of fossil fuels. Fossil, meaning that this kind of fuel comes from the remnants of old living things that are dead now. Fossil fuels are a non-renewable energy because there's only so many past dead organisms that could create fossil fuels. So fossil fuels is a big, probably not big enough controversy right now. It definitely, we're seeing effects of fossil fuels in terms of our heat, gas, oil, all those things are going up in price. Everything's getting more expensive because of just political issues worldwide, especially with Russia has a lot of supply of fossil fuels to like Europe, for example. The availability of those fossil fuels is going to just shift in terms of who's going to get what. So that's why things are getting more expensive. We even see that here from the war affects us too.
So when do you think
they can run out? So Jack just asked, when are they going to run out? When are fossil fuels going to run out? So in different parts of the world, they will run out first. It's availability. Even within like the United States, one of the things that has been proposed right now is for us to drill more oil in places that have oil storage underground in the United States so that it could lower our need for buying oil from other places, and that would make our economy in better shape. It would reduce inflation. When they're going to run out is, it all is dependent on, it's a lot of, see, the one thing that I hate about this lecture especially is that there's a lot of political control over the environment. And so I don't want to get too much into politics, but the push for renewable energy, wind, solar, water, hydroelectric, those things potentially could alleviate our reliance on fossil fuels. We're seeing a lot of cars, a lot of regulation within states of car manufacturers saying, the states are saying, you by 2035, by 2050, even within companies, they are pledging this on their own rather than being regulated. So sometimes some of these things are like regulated, sometimes they're chosen by the companies. They're saying we're going to go to electric as opposed to gasoline. And electricity has a lot more flexibility and reliance on renewable resources. So you can, when, you know, like ideally, and Germany is a really, if you ever want to read about a country that's doing really great things in terms of shifting their reliance off of fossil fuels and onto renewable resources, Germany does a lot of really awesome things. Most houses And companies in Germany have solar arrays on their buildings. And, like one of the things I would love to see is regulation of any new building gets a complete solar array. My house has a flat roof. If I could invest $30,000, which I would love to, but I can't just hey, here's $30,000. I don't have that right now, but something we're working toward. We could have 103% of our energy needs covered by the solar array that potentially could go on the roof of my house, which means when I say 103%, that means that we could fund our complete reliance on energy plus sell back a little bit to the grid, which means we could sell it to the electric company to fund other people, which takes not only our reliance of fossil fuels away, but also a little bit of everybody else's. And if everybody did that, if that was regulated, the problem is that like a solar array, $30,000 for the average person, even with rebates, there's rebates and ways that incentives to lower the amount, it's really about $60,000. And then $30,000 comes from rebates and things like that, and discounts, but we would have to come up with 30 grand. It's hard for individuals to do that, right? You have to be kind of rich. And so a lot of this changing, or you see Teslas, right? People who drive Teslas, they're not, even the lowest priced Tesla is 30 grand. Plus you have to then make sure you have the right electricity in a place to charge your car also. So that stuff is expensive and it's hard for the average person to do. So, then I could go on about, but now I'm going to get into politics and things like making stuff available to everybody. We just don't do that well. I know we talked about food the other day. We have 7 times the amount of food for people on the earth, yet some people are starving. So again, gets into politics and then the people who are in charge doing the right thing for their people, the constituents, and typically we don't see that happening. So the bigger issue of a lot of environmental stuff relies on the governing agents doing the right thing. And so what I would encourage all of you to do with social media, start a movement against, and regardless of Republican or Democrat, the problem is having 2-party system is they're all corrupt. Even if you're I'm a total Democrat or I'm a total Republican, they're both corrupt. All of them are corrupt. And it's marketing makes them look this way or that way. But if we had a 5-party system and any given voting year, any one of those parties could be in charge because they're showing the values that most people agree with, would be a better system. But we're so stuck in this 2-party system because of money and things like that. But as a group of people, we could disrupt the whole system by, let's say we're going to say one of you who's going to do the right things for the common good. What if we started an internet campaign using all social medias and contacted everybody and said, let's write in this person because they're going to do these right things. So we could do it if we're all sick of it. Problem is that as humans, it's hard to agree on one thing, right? So even if you're I said, you're going to be the person that's going to do this right thing, can everybody agree that they like that person? It's difficult, but it's not impossible either. So I just always think we need this groundswelling of disruption to happen. And we're seeing a lot more of that happening now. So I have a lot of hope for people who are sick of the 2-party system to do something else. We just got to figure it out and get together. So that's my really long story short. I could go on for hours and hours and hours about the complications of politics and humans interfering with all of this. So again, there's only so many ancient life forms in the fossil fuels. And then just to reiterate, fossil fuels are coal, oil, and natural gas, so all of those things. But so all of these add to like electricity, and we can get our electricity in different ways. And so we can change the system. Anyway, I'm gonna stop talking about that. All right, so carbon dioxide, you can see there's a lot of cycling in many different ways, because the two main ways we have are just respiration, so breathing, and then, so respiration is a big one of cycling. I should say three big ways. Respiration, and then in photosynthesis, which is part of this whole respiration thing, right? To make not only oxygen that cycles around into the carbon cycle, but also food cycle, the trophic levels. And then the other big way is the burning of fossil fuels. So there's three main ways. I'm going to count the decomposers as part of the food cycle too. Other smaller ways, but are getting to be bigger impacts, are things like fires. They add more carbon dioxide to the atmosphere. And we're seeing a lot more fires because there's a lot drier climate. A lot of climates are changing to drier, and that promotes fires, things to burn more easily, and less water. So the combination of like hotter, drought, that's going to cause fires to be promoted. The second example is nitrogen. This is a fascinating one because nitrogen is about 79% of our atmosphere. But you and I can breathe in a lot of nitrogen, breathe it in, breathe it out. But we can't fix it. The term fix in biology means to bond to and capture. So you can breathe in nitrogen and your cells can't grab onto it, but our cells can essentially bind oxygen and some other gases too. Nitrogen's a really important part, even though it's not the central atom, but it's an important part of very important biomolecules, DNA, RNA, and proteins. We know that DNA and RNA go through a process of translation and transcription, and translation. And they make proteins, but then the proteins that are made in this process go through metabolic pathways to make all of our other biomolecules. So essentially, that these two that go through a process to make that goes through biochemical processes, metabolic processes, to make all of our biomolecules in our body. So those are critically important to us. But if we can't fix it or bind it into our lungs when we're breathing, we've got to get it somewhere. So we get it through the food system. Plants can't do it either. Okay, so if we can't do it and plants can't do it, well, how the heck does it get in? Only there's a kind of bacteria called nitrogen fixing bacteria. And there's that fix term. They can bind it, grab onto it, incorporate it, and then they are going to leach it into soil around plants, and then the plants absorb it. The plants incorporate it into their bodies and then into also the food that plants produce and make it available. So then, that nitrogen can become part of fruits and vegetables and nuts and grains and seeds and etc. And that's how we get it, by eating. So the health of these bacteria in soil is really important. With climate change, if soil structure changes, or if we chemically are farming to a point where we kill off these bacteria, the amount of available nitrogen in the food we eat is going to go down. So there's like a lot of thought that has to go into this whole system, especially here, in soil. You can see here there is the nitrogen fixing bacteria. It's taken up by the producers and then passed through the trophic levels, broken down by the detritivores and decomposers. Decomposition puts that nitrogen back into the soil. We have what are called denitrifying bacteria. So you've got the nitrifying ones and the denitrifying ones, and then they make that available back into the atmosphere. Lightning, fire also are going to produce extra forms of nitrogen too. All right, so there's many biogeochemical cycles. I'm just going to mention two more. The phosphorus cycle. Phosphorus is in rocks. They leach phosphorus into the soil. Phosphorus is important. It's an important component of DNA and RNA, which DNA and RNA go through a process that create proteins. Phosphorus is in proteins. It's in many of the components of our body that get metabolized and passed through. So once the phosphorus is absorbed by the producers, gets passed through the food system, the trophic levels, to everybody else, gets put back into the soil by decomposers, detritivores. And we have that nice little cycle there. Phosphorus is super important. We could talk about a lot of elements, and we could go through their biogeochemical cycles and talk about their importance, but these are one of the big ones. All right, so, and then the last one I'm going to mention is water, the hydrological cycle. Water goes through, it's driven by solar and heat. Evaporation goes up, precipitation comes down. The problem with climate change is that climate change is causing more air currents and water currents, but especially air currents, that where you would have a lot of consistent evaporation, precipitation, what is happening with more air currents because of shifts in all kinds of weather events like heat and cold, is that the water will go up and then it dumps somewhere else that's not used to getting it dumped. And then where it's normally coming up and down, you get drought, and where it's dumping elsewhere, you get floods. So remember again, just to reiterate, that nutrients are recycled. You could have carbons that make up parts of your body that are billions of years old. You could have carbons in your body that were in dinosaurs. Energy gets utilized, and then it's gone. And then we have to replace it. Okay, so, sorry. So, do you think humans are, I just talked all about it, right? Are humans messing all of these cycles up? Yeah, we're messing them up crazy, right? So, here's where we get to some of the things, right? So, lots of ways. One, we talked already about our reliance on fossil fuels. We have to get away from that. Not only because it's going to run out in places, and then it's causing all this political wars and things like that, right? Causing issues. Also, fossil fuels the burning of fossil fuels puts more carbon dioxide in the atmosphere and causes accelerations of climate change. The Industrial Revolution, it's like kind of amazing that we think like that was so great. It gave us machines and all these technologies, but now these technologies that we eventually have made are killing us. So maybe we should have been just back in our like cave days, relying on more of the natural environment. And so it's like, we can argue Industrial Revolution is good and bad. Also, all of these processes that we go through in terms of creation of things in our world produces chemicals that go into the atmosphere, and then a lot of times mix with the clouds and come back down. So either they just drop down or they come down with rain. So we've got a lot of issues there. Okay, so climate change, global warming, climate change. Two related but different issues. They're very closely related. Global warming is a part of climate change. Climate change, so probably like 20 years ago, a lot of people were using, like up until that point, they were using the term global warming because they were noticing that the Earth was warming at accelerated rates, at unusual rates than it normally has been in the past. And then they were saying like, oh, well, what causes global warming? Well, the rise in the use of fossil fuels, industrial processes that cause more warming gases, like for example, methane, and I'll talk about both of those, methane and carbon dioxide are the two main causes of global warming. But then people noticed, they started to notice that other things were happening. Like for example, there's one place in the world where it's been getting colder rather than warmer. And so then people were like, well, can't really call that, it's part of the global warming because we have the shifting of the temperature somewhere else, so that little area is getting colder. And so this is an issue where misinformation has been utilized for a long time, that people and these people are oil companies. Let's use that as an example. Exxon Oil was busted 10, 15 years ago, sending letters. They are so bold. This company is so powerful. They were sending letters to scientists studying global warming and saying, we'll pay you $10,000 cash if you will falsify your data to say that global warming isn't happening or that it is not related to the use of fossil fuels. Because they wanted to keep selling their gas without the public knowing it was having a negative effect on the world. And so there's you could Google it, and you can look at one of those letters that they had sent out to scientists. Some scientists were like, oh man, my roof just broke. I have to get a new roof. I need that $10,000 now. I don't have it. And some people succumbed to taking that bribe. And they wrote papers that said global warming's not true because in this place it's getting colder, showed that data. In the study of that place, they pick and choose part of sentences and put them together. And so while they were using the source, they were using it incorrectly. They weren't using it truthfully and wholly. And so, it's just a lot of this nonsense happens in the world where somebody says something and they pull parts of sentences and put them together to mean totally different context of what they actually said. That's what some scientists were doing. And they were publishing papers, and then other people were like, no, this isn't true. But does that get politicized, or does that go into the media where it's like, no, this is struck down, it's not true? No. So that was one issue. Okay, so that's global warming, is that the Earth is increased on average in warming temperatures. In addition, people started noticing that there were, like I said, with the evaporation and precipitation, that some areas of the world that were having regular rain, that they started to have a drought because of climate, because of global warming, and the warming of the Earth was making the air currents shift and was taking water from one area and dumping it on another area. So they noticed that there was more drought and floods. And then other people were noticing, well, like California, how every year we have these crazy fires. And so they were like, well, that's getting drier because there's less water in that area. And then the fires are way easier to spread. And so that we're getting more fires in places. And so people were noticing all these really odd, uncommon shifts in the environment. And so then people started saying, well, it's not just that the Earth is warming, but other things are happening because of that warming. And so they felt it was more descriptive now to call it climate. The climate is changing because of warming. And so we don't really use global warming anymore. And again, you can, hopefully now I've trained you to read through things with a more critical eye, that when you see this nonsense, you can spot it. And you can go like, I'm gonna look at the sources, and then you start digging into it and you go like, wait, what? This was funded by BP gas? Well, that's something they shouldn't be funding research. They should let scientists do research without being supported financially by them. So there's a lot of issue. So the main thing is that we're just getting, increasing heat is causing chaos all over the place. Did you read that in Pakistan and India this week? Temperatures are 120 degrees. That doesn't even include humidity. So a lot of places, the average temperature was, I think it was 98 degrees across India and Pakistan, and some areas like the desert areas were up to 120. Add the humidity in, and that increases anywhere from like 2 to 10 degrees and how it feels. The human body can only withstand about 120 degrees, and then it can't cool itself. The mechanisms like sweating, for example, everything starts to go awry and we die. We can literally start shutting down organs in our body. So maybe you're like, well, we'll just go in the air conditioning. Only the richest Pakistanis and Indians can afford air conditioning. It's about, I think it's like, they said 90 to 95% of the population doesn't have air conditioning. There's 1.4 billion people in India right now. Oh, all those people that are getting bombarded with this. So just the heat issue to cool off is difficult. Now, even those who have air conditioning, a lot of people have at least fans, but some people can't even afford that. The temperature has messed with the availability of the grid for electricity to work correctly. So even those who could afford it, there's no electricity at all. So this is all like we're getting to a point of major danger on the earth. But here, we're good, right? Like, we're cool. Not much is going on. We're in a good area of the earth. As much as you might think, like, someday I want to live in California, it might be good to always keep a little bit of land here, because we have the Great Lakes to get our fresh water. You can read all about water wars that are going on and the politicalization of that. But we're in a somewhat safer zone. If you're especially like in the Chicagoland area, closer you are to Chicago, the less ability to be affected by tornadoes, which are another part of climate change, increased amount of tornadoes. So we're a little bit like removed from the effects of it, but being near a city also, we have the grid issues. And if climate change affects the availability of electricity, we could have everything shut off. So we're better than most places, but not completely immune. So as all of this is related. As carbon dioxide increases, temperatures increase, which increases all these crazy other events to happen. There's just, everything's connected. Everything is connected. So again, just like another way we need this groundswell of people to say enough. The earth is really getting messed up. Hard thing again is that people in like Pakistan and India that are majorly suffering, you can drink as much water as you want. You can take a shower for an hour and a half. We have the availability of everything. We can turn on our heat or air conditioning or whatever. We're not affected, but things are happening. So all of these in yellow are components that add to climate change. The producers on the earth can alleviate climate change to an extent. They're going to extract carbon dioxide, which is one of the leading climate change gases. But we don't have enough of those. And we're also then, we'll get into other issues too. So I'm gonna keep going. So this one. So the producers like on Earth, trees, plants, the very organisms that could take carbon dioxide out of the atmosphere, we are cutting them down. So think about this, that I like pineapple, okay? So pineapple typically grows in places like Hawaii. It's a good climate for pineapple. But there's a big demand because people like pineapple. So what I'm gonna do is, because I'm like some rich person, I'm gonna make farms, pineapple farms, in the Amazon rainforest by cutting down huge plots of Amazon rainforest, which has tons of different kinds of producers, trees and plants and shrubs, all kinds of variety, which support all kinds of variety of other plants, animals, fungi, bacteria, protists, a nice diverse ecosystem. I'm gonna cut all that down. And I'm gonna plant pineapples, which don't support much organisms or many organisms. And I'm gonna make a ton of money selling my pineapples. And after about 7 years, the soil, it's depleted of nutrients. And I'm like, well, I could put more nutrients back in the soil by some organic processes. Or I could just buy more land and tear it down and plant more pineapples again. And that's what people do, is that they just buy land, tear down everything, plant their one thing, and after about 5-7 years, they just move on to a next area and do it again and again and again. So we're depleting our producers at crazy rates. So the things that could take the carbon dioxide out, we're getting rid of them. One of the other things that they do is that sometimes, you could bring in big tractors to tear down everything, but those are expensive to transport down to areas of the world that have a lot of rainforests, right? It's hard to get there. So then they're just you know what? We're just gonna light it on fire and we'll burn it all. And burning living things adds more carbon dioxide. So we're doing a double whammy, right? If I wanna make my pineapple farms in the Amazon rainforest, and I'm I don't even know how to get tractors here to tear it all down. So I'm just gonna put a lot of gasoline on it and light it on fire. I'm adding carbon dioxide by burning the things that could take the carbon dioxide out. So it's like a double whammy there. So more and more carbon dioxide that goes in, higher and higher and higher temperatures around the earth. We know this. Anybody who says climate change is not happening has a money motivation to say that. That is absolutely 100% true. We have data that goes back even hundreds of years because we use ice cores. So what we see is carbon dioxide is on this upward trajectory, and temperature, even though it's not a perfect, right, temperature kind of goes up and down because we have air currents and different events happen in the world, but it kind of goes up and down. But you can see that this up and down trend is going up and up and up. Again, there is correlation. Rises in carbon dioxide, rises in temperature over time. So here's what we could do. Depending on the way that we deal with climate change will depend on how high temperatures go. If we had started 15 years ago, we'd probably be like this, where the temperatures would level out at a lower level, right? If they're here, they're gonna maybe lower out. We're still fighting to do the right thing. If we do something moderate, we'll get here. And if we continue on the track we're going, it's just gonna exponentially increase. Icebergs are melting, all these things that we hear. was reading an article about what's going on in India and Pakistan, and India's been having like really great wheat growing years. The last 5 years, they've had amazing growing of wheat. They've been a world supplier of wheat because of climate change. So sometimes it like benefits you, probably only for a limited amount of time, but then we see something negative happening right now. So in the Himalaya mountains, the icebergs up there have been melting, and so that water has been coming down to India and has been making their wheat fields fully hydrated. So India's been like, yay, climate change, because otherwise those icebergs on top of the Himalayan mountains wouldn't be melting. So that's been a good benefit for them. However, right now, this year, the wheat fields are getting swamped because their temperatures are so high right now. So they're getting increased amounts of water that are killing, they said about 20% of the wheat is gonna die off because it's too wet. Okay, so here they've been like living high for a while, but now we have this increase in temperature, this extra increase in temperature, and now it's like out of balance again.
What is the water also the production of like Himalayan salts?
Yes, yeah. So yeah, the Himalayan salts and in general, just like flooding is going to rush nutrients into places where it's too much. Yeah. So a lot of issues are tied to too much water at once. Wildlife who do migration, they're doing different migrations, sometimes not going as far, because if you live in Canada and then you're flying south for the winter because you want to seek out temperatures that are moderate all year long. So once Canada starts getting cold again, then they start going south. But maybe they only, instead of going all the way down to like Peru, because it's getting really, really hot there, they're like, I'm gonna stop in South Carolina and I'm gonna chill here. Those migrators may drop feces that have nutrients that all of the ecosystems down their migration path rely on. So the migrators not doing their normal migrations are not contributing what they normally contribute to ecosystems. And a lot of them are keystone species. So you're missing these keystone species and they're not contributing these nutrients, which are messing up the entire ecosystems that they're not going to. So sometimes it's like when you have to really think through things like this. Like, what does that actually mean? And then weather is changing all over the place. There's another weird thing is that, my son just said today, isn't it spring? Why is it still cold? Yeah. But definitely the seasons, since I was a kid, the seasons have shifted more. Yeah. And it'll come down again. And we are definitely seeing like a lot of unusual weather activity. One is that it's getting colder later. So fall has been like summer and nice, yeah. And even like all the way up to how many like New Year's days have been in the 60s in the last 10 years? A bunch of them. Yeah, so it's like New Year's Day, and then you're like, it should be like totally icy, crazy cold. It's 60 degrees. That's happened, I think, at least twice in the last 10 years. That's not right. We should be in a cold pattern, but then it gets colder later, so that you're seeing like January, February, March, April, even into May, chilly, or cold, right? So things are changing. I'm sure we've all seen these, right? Like, this is all ice. So this mountain right here, you can see, was covered in ice. Look at how much bigger it got over time. It's a lot bigger now, because a lot of the ice here, so it used to be ice used to be up to here. But now, you see the exposure between these two mountain ranges, you see a lot more exposure of the actual like mountain. So that means like all of this, you know, it used to be a lot higher, the water and the ice. Again, just pictures to show you. Things are melting, melting, melting. So let's get into some, like, maybe a little better. We're going to get like a little worse, and then we're going to get a little better. So we're going to look at the ecosystems. First, we're going to talk about more issues. Okay, so the ozone layer has been deteriorating. The ozone, so we have a bubble around the Earth. We have a couple bubbles. We have the atmospheric bubbles. The bubble is unique to Earth as opposed to other planets because we have this atmospheric bubble has been really great to promote living things being on Earth because it holds heat in and it allows us to exist in a nice, warm, protected bubble. But the bubble, again, like in terms of climate change, the more carbon dioxide, methane, the more heat in our bubble. So our bubble is getting too hot, and we see chaos happening. In addition, we have a different part of the atmospheric bubble, which is the ozone layer. And the ozone layer, ozone is made up of O3, so it's 3 oxygens covalently bonded to one another, as opposed to O2. And that bubble, because of industrial processes that I'm going to get to, is breaking down. The difference in extra oxygen is added on with another covalent bond. Yeah. Some of the O3 can get broken down into O2, which we might think like, that's great, more oxygen, but we need the O3. So, okay, so the ozone layer is important because it filters out UV radiation. UV radiation is important because UV radiation promotes the making of vitamin D. Most of us are vitamin D deficient because we don't go outside enough. 20 minutes a day. And I was reading something recently that said, like, one of the best things you can do in the morning is for 20 minutes, and this is more for your mental health, is get outside and be in sunlight and get a little exercise. So all of us, like I have a dog, so I get up and I walk the dog, and I'm like, okay, we're gonna go for like at least a 20-minute walk, and then I get that in. But the other thing is that 20 minutes of sunlight on my body helps me to promote my vitamin D, which also is kind of an important component of your mental health too. So you get like this chemical, and you get this like mental thing that by just a 20-minute walk the first thing in the morning. So I encourage you to do that. D vitamins are important for all kinds of things, especially like your eyesight, the strengthening of your bones, so 2 big important parts of your body. If you go outside, especially now as we're tilting closer to the sun, which means that we're getting more sunlight, more UV radiation. If, like me, for example, I have this very, 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 very low melanin amount in my skin. So if I go out in the summertime, and I'm like the tank top and shorts, and I'm like, woo, it's so great to be outside. If I'm outside in the sun for a few hours, couple hours, what's going to happen to my skin? What color is it going to turn? Red. And what does that mean? Yeah, burned it. So that's not good. Sunburns can lead to increased amount of melanoma. My dad has had like chunks of his nose cut off because they didn't really, think too much about that connection when he was younger. So he got a lot of sunburns. Regardless of how much melanin you have in your skin, you need to be conscientious of the sun. Even if you don't, like I have a genetic component clearly to melanoma, but some very light-skinned people may not. They're finding that even people who do not have a genetic component to being susceptible to melanoma, so you don't have that connection genetically, are getting skin cancer, or getting melanoma. So you gotta be really, really careful. In general, everybody should have at least a moisturizer with like SPF 15 in it. And you put it on before you go outside, even in the winter. You should always wear sunglasses outside that have UVA, UVB protection. And that's what you're also looking at in a sunscreen, or even like a moisturizer that has UVA, UVB protection, because there's two kinds of UV rays. So eyeballs, definitely. We're seeing more cancers in people who don't have that genetic predisposition. And here's another one. Somebody did a study and they saw that people who work outdoors, like construction, they were studying construction workers, and that they're getting cataracts in their 30s and 40s because they're outside like all year long, and many of them not wearing sunglasses. Cataracts used to be like a really old person disease. Now people are getting it in their 30s, 40s. That's crazy. So we're definitely seeing like more of this. One of the connections is that the ozone layer around the world, that bubble, is decreasing holistically, meaning the whole ozone layer. But then there are areas, like at the top of the earth, that it's like a hole. And that hole opens and it gets smaller throughout the year, depending on like wind cycles and things like that. So, the bottom part of the earth has that opening and closing of the ozone layer. But it's decreasing all over. So we're getting that increased amount of exposure, everybody around the world. Okay, so what causes the breakdown of the ozone layer? Chlorofluorocarbons, CFCs. CFCs are chemicals that are given off by aerosols, spray things, refrigerants, production of foam, like styrofoam, which we see a lot of, and other chemical processes, and a lot of plastics. I'm sorry? Oh. The CFCs are broken down in the atmospheres into oxygen. Okay, great to have more oxygen, but we don't need that much more oxygen. We want the CFCs to stay as an O3, or we want the ozone to stay as an O3. So the CFCs are causing the breakdown of them. All right, so here's some good news. In 1985 and then into 1986, a bunch of countries that did a lot of the processes of making aerosols and foam and refrigerants got together and said, this is a problem. Let's all sign a compact. We're all going to sign basically a promise document that says we're going to change the way we do things to lower the amount of CFCs that are produced in these processes. And so that's great, right? But here's a couple of things about ozone and issues. It takes about 50 to 100 years for a chlorofluorocarbon to float up to the ozone layer. So what that means is what we did 100 years ago, 50 years ago, is starting to affect us now. So just think for like the last 100 years, we're going to have major effects coming. They're coming. The other problem is that a lot of countries that are developing didn't sign this compact because they weren't developed enough yet to participate in making of all these things. So where are they going to start? With the cheapest way to do things to make money quick, because they didn't sign the promise, so they can do it quick and cheap and make quick money now. So we're going to see damage for a long, long time. So even if everybody today says, I'm going to participate, we still, again, what happened 100 years ago is what's going to happen now is going to affect us in 100 years. Oh, man. So one of you, if you want to go into chemistry and figure out how to increase the amount of ozone, you'll be a bazillionaire. All right, disappearance of the tropical rainforest. I talked a bit about this. All right, so like I said, with my pineapple farm, if I go in and I burn it all or I bulldoze it down, it not only gets rid of like the plants, it also gets rid of the bacteria in the soil, getting rid of denitrifiers in the process. We need those. It's getting rid of protists, good bacteria, archaeans, lots and lots of animals, lots of diversity of plants. So I'm getting rid of the biodiversity there. Who knows what has been growing where my pineapple farm was that contributed globally to something really, really important. Who knows? Oh, Nan, I thought you were raising your hand like, I know. Reduces productivity of the soil. We know, we talked about this. Get rid of the photosynthesizers and
So, I've noticed the Amazon rainforest is one of the things
I don't think it'll completely be gone because I think there are areas that are really difficult to get to. I also hope that we've had a lot of issues with, and this again gets political because people who govern countries that have the Amazon rainforest are getting money, me and my pineapple farm. So I go to the president of the country where I want to put my pineapple farm and I say, I'm going to give you $1 million if you will let me do this by not banning the cutting down of the rainforest in your country. And so what do you think that politician is going to do? Well, what they should do is say, no, the right thing to do is keep the rainforest. But they're like, I like money. So they take the money and they don't put the regulations down. So that could change a lot. It hasn't. It's gone in the bad direction recently. The other thing is that some areas are just too hard to get to. There's like big rivers and things you'd have to cross to get to tracts of land. That some land will stay protected just because it's hard to get to. So that's a good thing. Increased amounts of water will cause more rivers and things and make it harder to get to certain areas. Wait, start this at the beginning. There are, and again, it just depends country to country who owns that land. And some countries are protecting it, and some countries are like, come here, grow pineapples and cows and whatever else you want to grow. If you, they'll say, yeah, it's open, but they're also getting a lot of money that we don't know about. Yeah. So blah, blah, blah. At least 40% of the Amazon rainforest is gone. 40%. That's a lot. Bless you. Lots, thousands of species are being driven to extinction, gone by every year. Humans, oh humans. All right, and I think this is the last bad issue I'm going to talk about. Acid rain, industrial processes put some of those chemicals in the atmosphere, and then some of those chemicals come down with rain. Some of it is acidic. We know that like on the East Coast, like New Jersey area is a big industrial area. And what they've seen in those areas where they have a lot of industries and factories is that, so this is limestone. It has nice carvings. We have a lot of buildings like this in Chicago that have beautiful carvings into the limestone. The acid over time is eroding away the details of stone. Okay, so what is it? Nitrogen oxides and sulfur dioxide, make sulfuric acid and nitric acid. Those acids are the major components that are burning things. Now, if you go out to New Jersey, you're gonna take a vacation, go out to New Jersey this summer, and it rains, you're not gonna be like, burning acid. It's not that acidic. It's like a very small component of the rain. But let's think about like we're a big organism where there's a small amount of acid that doesn't affect us because we're a big organism. If you're a small single-celled organism, it's going to affect you really hard because you're only one little cell. So we're seeing a lot of decomposers and detritivores are being affected, especially the decomposers, the fungi and the bacteria that decompose because they're little. Fungi eat by slurping up their food, so they're slurping up that acid as well as getting it, just touching them. So we're losing them, which means that if we keep losing them over time, you're going to lose the nutrient recycling. And then, as we talked about that question, right, you're going to lose like a lot of plants because you don't have the nutrient recycling, which means that the diversity of the ecosystem is going to go down because then you don't have the passing of energy through the trophic levels. And a lot of dead things and waste are going to start to pile up. Yuck. Also, acidic water holds on to toxic metals like lead, aluminum, mercury. Then we're going to get increases in biomagnification through the system. So that's the thing that's so hard about these issues is that they're so much related because even with this, industrial processes not only are creating more acid rain, thus lowering of diversity, thus lowering of the decomposers, thus causing more biological magnification, and also contributing to climate change, and maybe a little bit to the breakdown of the ozone layer. So you can have just like one thing, right? I'm going to make shampoo in my factory, and I'm going to cause like chaos by doing that in so many different ways. So, yeah. If the decomposers and the detritivores are gone, then our ecosystem, everything, typically more freshwater ecosystems are affected than saltwater. Saltwater ecosystems are so big. Usually freshwater ecosystems are not quite as big, so the effects are harder. A lot of forests throughout, especially like I said, the eastern United States, we can see directly trees, the bark layers are getting burnt off. So over time they're losing their bark. Remember the phloem is in the bark, which transports the sugars, and then the rest of the tree is not going to get the sugar, so it's going to starve. So it's going to lead to starvation of the trees. So here, what you see in the forest is the forests look white because all the brown bark has been burnt off. Or you see patches. You can see on these trees here how much of the bark is getting burnt. Some trees are naturally white. They're by species. Yeah, so around here we don't see it very much. Those are just different kind of species of tree. All right, so let's talk about the different ecosystems of the Earth. They are called biomes. There's that B-I-O again. So this is where living things, we find them. We have them all over. We have a lot of different kinds. All right, so where all the living things live. Biomes are categorized or named because of weather and climate. Weather and climate are two very different factors. Weather is day to day. So I know this is like, these are also terms that are often used interchangeably in our everyday lingo or everyday just like language, but they are different. Weather is today, a daily thing. Climate is long term. So like think like What is it going to be like outside today? What is the spring going to be like? What is the winter going to be like? So we're talking short-term weather, long-term climate. Those two things impact what plant communities live in an area. So when they find certain plant communities, they're like, oh, because it has this plant and that plant and that plant, it's this kind of biome. They don't worry about animals. Plants are what they classify by because plants can't get up and leave, right? If like you have changes, like on the East Coast, maybe there's less deer because the food that they eat is dying down because of acid rain, and they're moving to the more western parts of the country. Well, they are like, I don't care about the deer, I care about what that plant is that's missing. Plants can't move, they can't get away from it. Sometimes plants are found in only one area of the world. Like, I think, I might be wrong, but I feel like macadamia nuts. One of the only places they're grown is in Hawaii. That's why macadamia nuts are very expensive, because they have to, and also if you want to be fascinated about the how macadamia nuts are harvested, it's a really cool harvesting thing. Cashews are another one. Cashews are crazy, the way they're harvested. That's why cashews often are very expensive. But anyway, in Hawaii, one time I went there, this plant called the silver sword is only found on one volcanic mountain in Hawaii, in the world. Only place in the world it's found. Just as an offshoot. All right, so we've got all kinds of ecosystems in the United States, or sorry, I should say North America. We're going to talk about a few of these. These are all the different like borders, and again, this is like not comprehensive, but it gives you major biomes of the world. There's a lot of other biomes that we don't have in North America. Like there's a lot of savanna, tropical shrub forest in Africa, for example. We have some coral reefs in the ocean, not on the land, some wetlands. Every ecosystem is limited by energy and nutrients, and that relates to the plant community, which also relates to the decomposers and the detritivores and the nitrifying bacteria. But energy and nutrients, right? I've been talking about energy and nutrients. Okay, so we have some tropical rainforest in Central America, maybe a little bit in like Mexico. But south, closer to the equator. Like this, even with like a little bit of like, if you thought these were like hills, it looks like over by there, not too far from us. It's very similar. There's lots and lots of greenery, lots, green, green, green. Okay, so let's talk a little bit about desert. We usually think about desert like maybe it doesn't have many plants and it's kind of like brown, but a lot of the cacti are green, and then there's short, very short growing periods and blooming periods. So we do sometimes see colors, like, but it's like usually there's a certain time of the year where there's a heavy rain, and then everybody flowers. So some of the details, this is really, really dry. We're talking about less than 10 inches of rain a year. That's it, scattered throughout the year. That's not much. So very low, which means that it can't support a ton of living things. The plants usually have very thick cuticles of wax. If you remember a little bit about the layers of the plant, the outer covering is the cuticle. And on cactuses, that's why the skin of a cactus is so thick, as opposed to like a spider plant, for example, very thin, is that they've got to have that thick outer layer to keep water inside of their body. Animals are really well adapted to these areas. They're going to encounter those like 100+ degree days a lot, especially in the summertime. And so they're active at night. They're more nocturnal. You don't see many animals out during the day if you ever go to a desert. And then at night, you'll see the animals have big eyes to take in moonlight when it's dark so that they can see better. And then they're usually colored like sand to blend in. In the United States, we're talking about the southwestern area. Okay, grasslands. We have a little bit of grasslands out in our area and definitely like southern Illinois, where all the farms are. If you've ever driven across Illinois or down through it, you see a lot of farms. This is what they used to look like. The grasslands, also called prairies, not many trees, lots and lots of plants throughout, from starting in a few weeks until fall. On a prairie, you can see lots of different flowers. Very flowery. Lots of insects like butterflies you'll see on a prairie. Central part of the United States, you can see we're right about there, just a little bit south of us, major prairie land. Oh, you have tons of diversity of life on a prairie. Cute, right? You used to have buffalo or bison roaming around. You can go out to Argonne in the northwest suburbs, and they have bison out there. They have a prairie. You can go and check them out. It's pretty cool. Nice little day trip up there. Fox, wolves, chickens, natural chickens out there. Skunks, bobcats, ferrets, snakes, mongoose, prairie dogs, antelope. So a pretty diverse ecosystem in terms of not only the plant community, but everybody else, fungi, animals. This is more so what we have around here, temperate deciduous forest. Looks like the rainforest during the warmer months. Around us and the East Coast and southeast part of the United States. So enough rainfall to support big plants, trees. The cold winters lower our biodiversity. Lots and lots of animals, lots of migrators through these areas. Because the trees, right, remember how the warblers could share the big tree so that they do not fight with one another. They lower their competition. The western part of the United States has some temperate rainforest. You guys, did you all miss something? You good? Is something weird? I just see a lot of flipping of pages. So, I don't have anything about this, do I? No. Okay. Yeah, so just a lot of rain, a lot of rain in these areas. The temperate rainforest is, you can see, like super duper lush. It's really cool. Giant, because they get a lot of rain, giant trees. I highly encourage you all to go out to the West Coast area and see the sequoias and the redwoods. They're so cool. So cool. There's a redwood tree. It's so big. They carved out the bottom of it. You could drive your car through it. That's how big around it is. It's really neat. Yes. So someday, take the trip and go out there. Northern coniferous forest. You're talking about a lot of evergreen trees because they're always green all year long. Again, lots of trees can support a lot of diversity of life too. Taiga, mostly evergreen trees, big sources of lumber. A lot of evergreen trees are lumber trees. A lot of diversity of life. Kind of where Canada into Alaska. Most of the, I should say, not as much diversity of life as it gets cold. Most animals are mammals that you see there. And then the tundra. Tundra is usually like this, but like the desert, has a short availability where this melts a bit to allow for growing. And we see adaptations to most of the animals up there. A lot of the animals are white, polar bears, the snowy owl, the Arctic fox, except for when there's a growing period, it can molt, loses some of its fur to grow this other coloring of fur to blend in a different way. It's cold there. It gets really cold. We have friends who live in Alaska, and there's days when they're like, so it's negative 60 degrees here today. How's it in your neck of the woods? And it'll be like that for a week, 2 weeks. So that means that if you go outside, what they generally do is they wear ski goggles, and every piece of skin is covered. So usually they don't encourage you to go outside when it's like negative 60, because you can get freezer burn. So yeah, like everything. They're like, everybody has their goggles on, the ski goggles, because it keeps the warmth in, as opposed to sunglasses, which cold can get in there. Cold, cold, cold. It's called, the soil is called permafrost because it is permanently frozen. Do you think things grow there? Not really. There's very few things that can grow in frozen soil or in snow. Mostly mammals, some birds like penguins. Most animals have very big blubber or fat layers to protect and keep their organs warm. All right, so just like biomes. The detail that I've given you about the biomes is what you need to know. Very general stuff. Should be, if I ask questions about what, give a description and say choose which biome, it should be so obvious if you've gone over it a few times. Okay, and then just a few things about biodiversity. I'm sorry, we got to get through this. Hang in there with me, please. Biodiversity is the variety of living things on the earth. Not only just variety, but the interactions of that variety of living things. That's often like a piece of the definition that's missing. All right, so let's just look at this question. Why is conservation of every organism in an ecosystem, even the bacteria, even a single species of frog, important? I probably should have an E, right? That is all of the above. I should have an E, right? Every one of these is right. I won't put anything like that on the exam. Okay, so for humans, we look at biodiversity in probably a different way than other organisms do. I mean, because we have this weird cognition thing. So anyway, we look at ecosystems like, what are the services that an ecosystem can provide me to enhance my life? We're so egotistical, or ecotistical. Okay. All these things. So if we paid better attention to the way organisms utilize natural organisms utilize their ecosystems, and we modeled our lives after that, it's called biomimicry, we could have a super healthy life. So, for example, when someone who's like an architect, and there's a lot of architects who are getting trained in, not biomimicry, is it biomimicry? I know biomimicry means one thing. There's another term for it. It's probably in here. just modeling the way you're doing human things after the way living things do it. But a lot of times they're like, okay, I'm going to build this building next to a wetland, and they're going to utilize the water system to interact with the wetland, because the wetland has a lot of species of plants, algae, and other decomposers and detritivores that will help to break down any wastes from our water system that we output, run them through the wetland, and we can incorporate that clean water back in. And so that's like one of the things that they're doing. And then putting like solar and wind. And so people are utilizing, thinking about how nature works into building. And when we do those things, not only does it cost energy cost to go down, it's cheaper in the long run. It's usually a little more expensive in the front, but cheaper over time, and it's so much healthier for us, because we look at us, right? We're talking about ecosystem services, but it's also healthier for all the other organisms that we interact with. And again, if we just did everything like in that manner, the world would be a much better place. So ecosystem services can be like directly the way that we grow food and eat food, the way that we build things, as I mentioned there, the way that we utilize fiber. Bamboo and hemp are very strong fibers and very cheap to grow. Very much easier to process than cotton, for example, and they use less water than cotton to grow. So the way that we like make our clothing is, a lot of it is political. Again, like hemp gets lumped into the marijuana category, and so it's deregulated. Like you can't grow big fields of hemp. But if we allow that, and hemp also has like, you could use part of the plant for clothing and part of the plant for food and milk. Like hemp milk is, and it's super healthy. It's got a lot of good proteins and fats in it. So anyway, fuel, we talked about fuel many times. Medicinal plants, if we grew medicinal plants, a lot of toxic animals have anesthetic properties in them. We talked about like the tick, how the tick has, ticks and leeches have anesthetic properties to them. So there's a lot that we could study for more natural medicines, and in general, how we replace oxygen. Indirectly, you've got a whole bunch of other issues that would result, like if you have your building next to a wetland and it rains a lot, the wetland is going to absorb that water. And because you did that, you're going to reduce flooding and erosion in your area. And we talked about some of these other things. So anyway, ecological economics is just calculating what's the cost of these ecosystem services in terms of both like money, the environment, and damage. So again, if we had regulation of like, they said in the United States, here are the ecological economics that you must meet, and a lot of them go with the ecological services, and you got to do all these things in order to get a permit. You got to show you're going to do these things, and then you get regulated by somebody checking up on you. We just don't do this enough. Okay, so ecosystem services could provide look at this, trillion, 125, 145 trillion dollars. Those are our benefits. That could be way more, way more. So a little bit about measuring biodiversity. We measure in terms of species diversity. And if we kind of look at what's the species diversity here, in conjunction with ecosystem services, we'd have a lot more biodiversity on the Earth. So there's all kinds of interesting in terms of like environmental, especially I'm hoping even in the fields that you're all going into, this will touch you in some way that you'll be like, oh yeah, I remember a little bit about this. I'm going to be more conscientious of this and that and incorporate that. You're going to look at your ecological footprint, the impact that you have on the Earth, and then thinking about that and your impact, the way you live your life. What if everybody lived their life like you? How many Earths would we need? We typically need, I think we need like 1.4 Earths on average for everybody to live right now. Like if we just averaged out the way everybody on the Earth lives, we need 1.4 Earths. How many Earths do we have? So we're far exceeding the resources that we utilize is the point. It'll be interesting for those of you, I know some of you have completed already, I've seen some 8 point something Earths from students. I'm like, whoa, that's crazy. All right, biocapacity. We look at the use of the Earth in a little different way. We call it biocapacity. How can we sustain the Earth in the way that we live? Oh, wait, no, acres, okay. And this is like the amount of acres that everybody needs to live. So we have enough space for, I think we're at what, 7.8 billion now? Everybody needs about 5.9 acres to live their life on average in the world. Sorry, everybody needs 6.9 acres to live the way they live, but we really only need 5.9 acres for each person, which again means we're overusing. We have exceeded our biocapacity by almost 30%, 1.3 Earths, there we go. That was in 2019. Yeah, I think we're at 1.4 Earths now. 30%, we're beyond by 30%. We gotta make it up, but we're not. We just keep making these figures this bigger, this bigger, this bigger. That should be coming down, 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 down. Okay, get up. All right, so here's our biocapacity. We call it a biocapacity as opposed to a carrying capacity. Carrying capacity is like natural organisms, but there's nothing natural about us. So we're talking about our biocapacity. We've exceeded it. You know, so a lot of times people will say, well, what's a carrying capacity of humans? It would be so difficult to figure out because we use the Earth in such different ways. And again, here's this looks a lot like the carbon dioxide, right? That hopefully we would be getting to a leveling off, a little bit higher than where we should be, or we're going to keep going up if we do moderate, or it's going to just exponentially keep going. In countries that have more resources, people typically use 12 to 24 acres of land per person. I'm not meaning that you have that many acres, but all of the resources you utilize would take up that amount of land. In Africa, they're using about 1 to 2 acres. Remember that 5.9 is the average. So in countries that have a lot more money and resources, like money, they're way beyond it. And in countries that don't have as many resources, they're way under it. So sustainable development, again, all these like little terms that I'm hoping that we're going to see more of, I wish and hope. The idea of sustainability, it has a more complex definition than just maintaining, right? The word sustain means you're just going to like maintain where you're at. Sustainability means that the way you're living your life now, you need to think about how am I living my life now? How is that going to affect future generations? Because most of us think a little bit more about just like, what am I doing today, right? And how I'm living, whatever. But if we all thought about how we're affecting future generations, that would be a different ballgame. Again, very political. I'm not going to get into it all. So A lot of people are working out there to live by these more sustainable means and making bioreserves when they're building, which gives living things an untouched space. And so, like, let's see the bison out at Argonne. They have given them a space where no humans can go. It's very natural to the way they normally live, or would have normally lived before humans. And then you can go and you can like drive around that area. They have picnic benches. You can sit and look. I mean, granted, the bison can move. We went and they were like way over there, but it was rainy. But a lot of times they'll come right up to the fence and you can look at them and you can sit and have like a lunch there and chill. So they have these like zones of use for humans around natural things. And that's, I mean, I think anybody in the earth, you see like a cool thing, living thing, and you're like, wow, it's intriguing, right? So it could draw a lot more people. That's why zoos and aquariums are so popular, because you get to see things and learn about other animals that you wouldn't normally be able to. Yeah, so we are seeing a little bit more of that. And here you can see like there's what's called the core reserve. It's completely protected, no humans. Maybe there's a buffer zone. Perhaps they allow, you know, like you can sit and have lunch, or maybe you can go camping in this area and look at what's going on in here without touching it. And then the transition area is like kind of leading you out into the normal everyday life.
So is that kind of what a safari would be like?
Safari a little different because they often you do go into the core reserve, but not as much. Like they'll only allow a certain amount of people per day. So similar. There's a little bit of rule breaking there. Yeah, there are probably some areas that they can't get to, but I think it's more so because like there's a stream or trees or something. And then this is a unique biosphere reserve in Mexico. Look at all this in Mexico that they have protected. So it can totally be done. There's a lot of people who live around these areas. All right, so who cares? Who should care? Who should care? You should, right? All right, so there's all these like reasons why you should care. A lot of them, one, it's like we should just do the right thing for other species on the earth, but a lot of people don't think about that. Maybe you think about like, especially some of you are going into medical fields, maybe one of you will do research on some like poisonous species and create a new anesthesia or a new pain medication that would not make people addicted to that pain medication because it's more natural. And in general, just the use of raw materials. Okay, if you're like, whatever, I don't care about any of them. I'm sure you care about getting cancer. That living in all of these ways I mentioned will cut significantly down on diseases. A lot of toxins accelerate heart disease and diabetes. Like smoking increases your chances of these. Animal-related diseases. That's probably where COVID came from. They hypothesize it came from probably like a bat or something in a market in China. We're seeing more and more of these, remember the zoonotic diseases. COVID is one of those. So these things, if anything, reducing everything else, it's going to cause you less pain. And so that's why I was like trying to get to people in that way, if they just like, well, I don't really care. And then, you know, this we're definitely seeing, we'll see more and more and more of this. And more and more and more of that. So, anyway. Yeah.
This is the slide that...
Oh, okay, yeah. So, so just suggestions that you can do. In general, just think about what I'm doing, living in the way a natural, everything other than humans would live. And if you think with that mentality, like drinking bottled water, for example, right? you guys are looking at that in a lot of detail this week, that do natural organisms drink bottled water? No, right? So utilizing that plastic is not emulating natural ecosystems. Eating a ton of meat, I mean, you can look at a natural ecosystem, but the top predators, there are not that many of them, right? So most organisms are omnivores, and there's a lot of herbivores, so like think about that too, and your consumption of stuff. So just in general, think more naturally, live more naturally. All right, so that